Hello, everyone. Uh, Emo's not here today, so we have a guest host who happens to also be the one presenting the feature. Today, we're going to resume talking about the ASN Reader Writer proposal, which previously had 1 hour, and we made it about a third of the way through. So, theoretically, I need to make my screen bigger. And in Teams, you guys might like me to also be sharing my screen, huh?
Yes, please.
I gave it to YouTube.
Uh,
Why are you so
Oh,
greedy?
yeah, we see it now. Otherwise, we'll just use our imaginations.
Okay, cool. All right, so one of the things we are not going to talk about unless we somehow finish is the namespace problem. We have we've now started a discussion on that one, and we'll get back to it later. Instead, we're just going to go over the shape of the classes and assume that the namespace will fit. So we also previously covered all of the general structure that's common to both the reader and the writer, and then the state of the writer of clear back to zero data. We made it no longer be disposable. Try encode whatever we rename values equal to. So now, until we finish the writer, everything should be about putting data into the writer. So one of the things that I've tried to make sure in the writer is it never blocks anyone from doing anything legitimate, even if the writer itself can't represent the value. And so this is the catch-all method. So write encoded value, you give it a set of bytes as long as the outer payload looks like it is one ASN encoded piece of data, then it will just copy all of the data directly into the stream. It won't do recursive checking on the data. It could, but it currently doesn't. And this, of course, allows anybody to do anything. So takes bytes and is void.
Jeremy, I apologize. I missed the first hour of this. Can you give me the two-sentence description of where ASN.1 is used?
So currently within our code base, the primary use case is in certificates and in cryptographic key file formats,
Okay.
but it's also used in LDAP. The certificates are X509, X500 is the directory, so they kind of came together. Yeah, so certificates in LDAP, or I guess cryptography and LDAP, are the two biggest consumers. It's I think I've also seen it used in um, like embedded device communication because it's just a general data encoding. So,
Okay, thanks.
okay, I assume write encoded value has no objection. Oh, I guess this is the first place where we're seeing cryptographic exception pop up. Uh, so I think this one will sort of come with the namespace. I have it as an open question at the end of what, like, as soon as we move it out of system security cryptography, cryptographic exception doesn't make any sense. The only reason it is that is the existing certificate code used Windows crypto APIs. If they failed, we threw a cryptographic exception. So when we started making the managed version, it threw cryptographic exception for consistency. Um, and so anywhere you see cryptographic exception here, it means whatever exception we decide at the end.
Sure. And even if it is under the cryptography namespace, you still don't think that it would make sense to make that argument exception or anything like that?
I guess in this one it could be an argument exception. Really, it's a cryptographic exception because when it asks the reader to validate it, the reader threw. But yeah, so writing
I
coded
see.
value
Okay.
should throw argument exception.
Another question on that. Uh,
The the parameter name is pre-encoded value. The method name is encoded value. Is that mismatch potentially going to confuse people?
I can rename it to encoded value.
Sure. What I was wondering is someone going to look at that method and think, oh, this is going to encode the value as it writes it? But honestly, like the documentation should be clear enough there, as opposed to a standard write value routine. Okay. I've talked myself out of it.
So you think pre-encoded value is better?
Uh, no, I write encoded values, I think, fine, especially because the documentation will clarify, but I would just prefer the parameter name to either be the same or just drop encoded from the parameter name, just for terseness.
So just value.
Yeah. Because the method name already says it's encoded, so
Yep.
why does the parameter name need to repeat it?
Fair enough. Okay. So now we're going to go through. So I have this set up as data type by data type, where data type is in the mostly in the ASN1 sense, and so everything. There's always two overloads. While the general overload rule is extra parameters go at the end. In this case, my opinion is when you've specified an explicit override tag, that is different enough that it should be important in a code review. And effectively, I'm saying the tag and value.
Code review such that one of these is more understandable than the other. Like if I just see write Boolean true, uh, I'm supposed to know that there should be a
In definition. So if you see the tag whose class says universal and value says 1, that means the value is a Boolean. So that's the normal case. There are times that you need to say, I have an application specific tag, like this is application 3, meaning only the application knows what it actually means. And so you want the value to be encoded the way that a Boolean would be, but you've changed the identifier to say something custom. That's sort of unusual, and I mean, it happens all the time, but like, uh, it's not the default stance. And so it's when looking at it in code review, it's like, oh, this isn't writing down a Boolean. This is writing down an application 3 whose value happens to be FF.
I guess I don't get it. Why that would dictate the order changing.
Fair enough. For Boolean, it doesn't really make sense, but when you get longer, complicated expressions, the tag override being buried to me felt sort of like burying the lead.
It just seemed like even just looking at the description of the method, write a Boolean value with a specified tag. Uh, that's like that almost seems to dictate the order.
Okay.
It feels like the tag is the optional thing, and therefore it should be secondary. I mean, maybe we can come back to this when you say other data types are going to make it clear why the order matters.
Uh, yeah. So I'll take that note, and then as we get later, if you change your mind, that
All right.
just speak up. All right.
The other question I had is, I believe in some of our APIs we've left the data type out of the right name.
So the reader, because the reader will always need the type name, uh, the writer has it for symmetry.
What did we do like with JSON reader and writer?
I believe we left it in because so later we'll get to a point where you can't infer from the arguments, like only the method name changes what the encoding was, and so I think when we hit that in JSON writer, we then went back and added it to everything.
Okay. As long as we're consistent with what we've done in the past.
Okay, and the object dispose will go away because the writer is no longer disposable. Sure. All right. The other things that are not complicated are you can write a null, and um, so object identifiers. This is generally these are represented in documentation as a dotted decimal string. That's the one that takes string OID value. We also have a rich type in .NET System Security Cryptography OID to wrap this, but depending on where we put this, it's probably fine to just drop the OID overload.
Is there a way to go from an strongly typed OID to a string?
OID.value. Which is why the string is called OID value. It's a hint of remove the period.
Let's see.
But
If
yeah,
we got rid of the first overload, would we just call it OID?
I could go either way.
I don't necessarily mind so I don't mind them all having the same parameter name, but again, if the method name already includes object identifier, or hopefully just shortened to OID in the method name, don't we normally just use value as a parameter? Because I mean, this is basically a TLV data format.
Yeah. Right. So I guess one reason to keep OID value as OID value is the OID class itself accepts either a operating system dependent friendly name or the dotted decimal, and this one will only accept the dotted decimal.
Do we have places elsewhere in the framework where we accept a string OID?
Only the OID constructor. So
Okay.
it's probably not super confusing, but
Okay. If it's, then I would just say use whatever you think is friendliest. If we had precedent, I'd want to use that.
yeah. Okay. And then the tag on those will do whatever they do. All right, so the all integral types in ASN are the same type, integer, which is an unbounded signed big Indian value. So it definitely makes sense to support the, int, uint, long, and ulong. I don't think there's really value in having the extra overloads here for short and sbyte.
And they can't have tags.
They can, and apparently I just copy pasted and didn't put them in here.
Okay.
Yeah, so all of the ones at the top should have their ASN1 tag overload as well. So I'll take a note on that just to make sure it's true. So big integer, I think, will depend on layering. If we have it in a place where big integer is available, I think it provides value. If we don't, the fact that big integer now has the 2-byte array signed big Indian means that you could just take that and pass it directly to the read-only span of byte overload.
Help me understand. So these are functionally equivalent. Like the right integer that takes an int is functionally equivalent to the one that takes a right integer a span of byte. Just like
yes.
So then, and any integer value is valid.
Yes.
Then what does it mean?
Up to 2 to the. It goes up to 2 to the 2 to the 2 to the 255.
So then, what does the error on right integer that takes a span mean about the significant bits being set or unset?
Right. So this one has actually been slightly contentious amongst the people using it in the preview. What I have, the current definition that I have for right integer is you can give it essentially the bytes to directly write into the payload. Uh, and the rules of ASN encoding are you have to use the fewest number of bytes possible for the integer value you want to specify. So -1 is just FF. The rules end up, the way that that gets expressed is in the 0 byte of the span. If all of the bits are equal, so it's FF or 0, and the high bit of span sub 1 matches what the first bit said, then you have at least one wasted byte because you could eliminate the lead byte, and so that's an encoding error. And then the question becomes, should this normalize or should this validate? And what I wrote was validate, but some people seem to want normalize.
Is there a scenario for getting the byte array or the span, writing into a span of bytes the encoded version of the numerical values from the overloads earlier?
Right. So the reader will expose a give me the read-only memory that corresponded to the encoded value of the integer. And so if you were just writing I'm copying one structure to another, then you would do write integer of read integer bytes. And so that's what the method was designed for. But in cases like RSA parameter structures and other big number byte array things, there have been, why can't this just fix it for me? And if we do that, then it would need hey, I'm the same as I added to big integer of, hey, I'm giving you some data, but it's really unsigned instead of signed, and then the overloads get more complicated.
Okay.
So, does anyone want to have an opinion on validate versus normalize?
Don't really have a strong opinion, honestly. One could maybe make the argument that normalizing is better from the perspective of if you call the binary primitives APIs and it gives you back something that's exactly 64 bits, for instance, that you would shrink it to the appropriate size before writing it. But that's a bit of a stretch.
Oh, I have to shrink it to the appropriate size before writing it. So the question is,
yeah.
Is the shrinking done inside write integer span of byte, or do you have to do it before calling the thing? And before,
is it semantically different?
I mean, being validate versus normalize means it's telling you obviously don't understand what you're doing. Normalize, like I said, the only complication is we then need, or we should then say that the input you're giving is unsigned data, so it needs to insert the padding byte for you if appropriate. Because only you know what your bytes actually meant. But it would always be big Indian because I'm not that nice.
Yeah, I mean, you already have it here as validate, but don't normalize. Let's just keep that and see what falls out, I guess.
All right.
Yeah, I think it would be more straightforward to require the user to normalize. That way we don't get into situations where, and I don't know if it's true for this case, but you already have normalized data and it accidentally gets normalized again. It just forces the user to understand what's coming in and what they're putting through.
Yeah, that was the position I started with. And then I got a little iffy about the third time that I wrote a normalization helper. So, but okay. So the next general data type, tag 3, is called bit strings. They're sort of almost exactly what you would think they are. So bit strings, you give a series of bytes. So let's call it a read-only span of bytes, and they simply get written down. But because it's trying to convey something that may not be an a full number of bytes. The bit string encoding has an extra byte that says how many bits in the last byte are only there because computers like multiples of 8 bits. So if you were only trying to send 2 bits, you would have the high bits of the 1 byte you're sending be semantically set, and then you could report an unused bit count of 6. I have it here, unused bit count, as a default parameter because very few things that say that they're encoding data as bit strings are actually using them as bit strings. They're almost always full byte semantics. There's a caveat, which we'll get to. It's technically considered a different data type. So now, when we come back again to normalize versus validate, of the 3 encoding rules that the writer supports, Burr says you're allowed to do whatever you want with unused bits. Sur and Dur say they must be 0. And taking the stance that the writer doesn't do any data normalization right now, that means if you report an unused bit and it's set to 1, then this will throw an argument exception. Actually, it says it'll be a cryptographic exception, but I'll change it to an argument exception. Objections?
No objections from me. Does it, just out of curiosity, does it make sense to have overloads that take bit array?
Where's that in our layering?
That is an excellent question. That is under system.collections.
Okay, so yes, I added a note for consider a bit array overload.
I don't know how commonly used the type is, to be perfectly honest. It just seemed like a candidate.
Yeah. I think the question would be, we need to understand what the ordering is, because technically bit strings order as the leftmost bit in a bit encoding is bit 0. And I don't know if that's the way that someone would be thinking of things in a bit array. So that's the only reason that I would hesitate, but I can definitely look into it.
Sure. The only real reason I brought it up is because I'm like, well, it would allow someone to just elide completely the unused bit count parameter. But whatever.
That's true. That overload would not need one. Which doesn't need a bit. Cool. Okay, and then I have a complicated thing. So one of the things that I found when using it is that a structure says that I need to write something as a bit string, but I have it as unconnected pieces of data. And so I took the string.create callback method and applied it so that I didn't need to do temporary buffers. If we think that this is too complicated to add, I can cut it.
The thing that immediately jumps out to me is that we have both a byte length parameter and an unused bit count parameter. It seems that we could just have a total bit count parameter or something like that. But I don't know if that would complicate matters, though.
How separate from Levi's question, like the performance requirements for tools using this or for code using this, is it possible it's on a hot path?
I mean, everything's possibly on someone's hot path,
Is it
but
likely to be on a hot path? Like I'm questioning the span-based callback here suggests that we're concerned about every allocation.
right. So this is used in elliptic, like this particular overload I added for elliptic key export, or yeah, so the elliptic key data file export, which shouldn't really be on anyone's hot path. But I don't know when we start adding managed LDAP support so that we can get some LDAP stuff on Linux. I don't know if that's going to be considered anyone's hot path, and it may need to start encoding messages.
But what does this API allow that the previous one doesn't allow? Because if someone, I mean, someone somewhere is going to have to write into a span somewhere. I guess the only thing this prevents is a memcopy, and memcopies are pretty cheap.
Right. This just saves you the trouble of renting a byte array, copying from 4 different sources to pack the data the way that it's supposed to be, and then calling write bit string and then returning the rented array. So it saves on temp space. Or rather, it saves on temp space ceremony. But yeah, I can
Well,
remove it.
well, okay, never mind. Yeah, well,
Um,
I would suggest starting without it and seeing if we need it.
yeah, I agree.
Okay. Yeah,
Going back to, yeah. Sorry, go ahead.
it is currently used in our internal code, but I think really I was probably just playing with the callback.
Going back to the write integer for a second, there was a YouTube question, which is there might be a need for some applications to write non-normalized integers. Would the write encoded value API that you mentioned earlier be appropriate for those scenarios, or would they not work for that?
I mean, if they needed to write an incorrect value, the write encoded value doesn't understand if your value is correct. It only understands if your tag and length are well formed.
Okay, so if you needed to write something that for whatever reason someone needed to understand, even though it's not a normalized form of an integer, there are ways to do that. Basically, imagine that you're interoperating with an implementation that needs to read an integer as a fixed length, for instance.
Right. I mean,
Is there a way to do that?
I mean, at that point, they're not using ASN because
Right.
the Burr family says an integer must be encoded using the fewest possible bytes. Well, it says octets because they like the word octet.
Sure.
But glancing at the chat, assuming that you're relaying Philip's question, I think his is more what I brought up of if you're doing RSA parameters, that is a big Indian unsigned integer, which means you need to know that you need to insert a padding byte if the high bit is set on byte 0, which is where I started having cracks open in the always validate never normalize damn.
Yes, and this is also why I think you having a big integer parameter alleviates that problem to a decent extent.
Right. I mean, you'd still need to take the byte array and load it into big integer, and correctly telling it you have an unsigned big Indian value, and then you can call write integer and it will do the right thing for you.
Yeah, but once you go through big integer as the intermediary, I think debugging probably becomes a lot easier. Because you can actually like look at it in a debugger, and big integer will say this is what I interpreted the value to be, for instance. But I don't know. I'm just I'm running with this question basically.
Yep. Yeah, like
Okay.
I'm on the fence now. I don't know if we have a general pattern of going one way or the other. I know that in general I don't like coercive API because it leads to a lot of subtle bugs that we have to maintain for forever. But this one may not be subtle. Like if it's simply the same algorithm of run it through big integer without all the temporary arrays, then like we could certainly do it. Okay, I should leave the header up. Okay. In ASN, there are two collection types and two structure definition types. So sequence of and set of are both collection types. Sequence of is an ordered list and set of is an unordered list, asterisk. Sequence effectively is the same as defining a data type because it's telling you you will see these fields in this order and they have this semantic meaning, as opposed to it's a collection. And there's technically a fourth thing called set, which is you will see these fields, they have this meaning, they don't have to be written down in a prescribed order. I've never seen it used, and there's a paragraph in the spec that is very ambiguous, so I don't support it. So that's the lead-in. So the model that I have here, so because everything is length prepended and the length is in bytes, a sequence won't know how big it is until it's closed. So I've gone with a push pop model. So push sequence with 0 parameters pushes the default sequence tag, and push sequence with the tag will push that sequence tag. And then the pops to match it, which will throw if you are trying to pop, if it's a set and you're trying to pop it, or if it's, actually I don't remember that. So I only check if the tag is right. So technically you can, I think, call push sequence with context 0 as a tag and then call pop set with a context 0 tag, which then will just skip set normalization. No, it'll do set normalization. I could harden that. One of the things that, so when we were revising framework design guidelines, we added the consideration for if you have a thing like a push pop pair or like lock, take and release, making a disposable wrapper around that operation. So that is a thing that I wanted to test our appetite of at this level. So that would be essentially, using open sequence, and then the dispose of that will call pop sequence for you with the tag that you pushed.
What are the common calling patterns here? Is it likely you're pushing and popping in the same frame? Are you likely pushing in a helper and popping somewhere else?
At least 99% of my usages of it, I say push sequence, open curly, do some stuff, close curly, pop sequence. Or yeah, I think I actually usually put the pop sequence as the last line before the close curly. And that's when I'm being sequence, aka an ordered list of fields. And when I'm doing sequence of, it's push sequence for each pop sequence. So I don't think I've ever pushed in one place and popped in another. But I can understand people write all sorts of helpers.
Were you suggesting open sequence as a replacement for this, or as something that would sit alongside these?
So the couple different things that I've thought of since publishing this is, one, make push sequence return a disposable thing. If you ignored it, you could call pop sequence yourself. Another would be to make open sequence, which does push pop and leave push pop as is. And another would be push sequence returns the disposable state, which I can make be an idempotent, mostly idempotent value type. And pop sequence becomes editor browsable never. or even internal, I guess private. So any of those combinations of things are, I think, on the table for what we feel is a good pattern going forward.
Do we, and this is actually a good question for you and Steve, do we have precedent now about using the using statement for anything, for things other than resource management? Because this isn't really a resource to be managed. This is a, I just want you to call this when the scope ends.
We've not done it before, but I know it's a common pattern for things that aren't the BCL. And so in framework design guidelines, it was suggested as a consider. And so now this is the test question of, do we want to consider doing that in the BCL?
Sure. And what happens when you call dispose twice?
Like I said, I can make it be idempotent. Like it can remember where it was in the state and understand that it's been called twice.
So Eric had a question on chat, which I think is a good one. If you make this a using, encourage folks to do it, exceptions that emerge from the body are going to cause the popping at the end. Is that desirable?
Oh, I guess that would be bad. Because then because now the finally is going to throw, and does the finally throw beat the original throw?
It does.
Yes, and that's why I asked, like, what happens if dispose is called twice? Like, does the second one throw, basically?
Yeah. Yeah, so, I mean, the dispose would throw if pop sequence would throw, unless it threw because it thought it had itself already run. So it would be pop sequence with some ceremony. But throwing out of the middle and then pop sequence complaining that you had done, I guess if you did everything with a using, it would balance out. But
well, what you would find is that if an exception occurs in the middle, the using statement, the dispose on the using statement would throw and hide the inner exception.
But it wouldn't. So if you had using push sequence, then you had some code and anything in there threw an exception. The pop sequence, technically the only reason pop sequence would throw at that point, or the only one that it would throw at that point that I can think of, is we're ooming. Like we just can't grow the structure to write down the next value. At which point you either get an from what you did, or you get the from pop sequence. But the pop sequence wouldn't fail due to an invalid state unless you manually called push sequence. So as long as everything was done using usings, the pop sequence would always be valid, and wouldn't have a payload based throw.
Even if you call pop sequence manually in the middle of the using block, but that doesn't match what you said earlier about assuming everyone's using the using block only.
Right. If you called pop sequence, then it would, like I said, I've sort of prototyped it in my head, and I can make the pop sequence understand, oh, my sequence has already been manually popped.
What are we writing to here? Like, is push sequence doing I/O?
This is all in memory buffers because it needs to regrow them. Whenever pop sequence is called, if you wrote more than 128 bytes of payload, it has to go shift everything by some number of bytes to go make space for the length. So this can never go to a stream because everything that you do, essentially you don't know the second byte of the payload until you know what the last byte is.
Let's see.
So this is always just using growable buffers.
I see. I would go without the iDisposable.
Okay.
It would be easy enough for someone to add as an extension method if they really cared.
Yep.
And we might even find ourselves doing that in our own code, and if we find ourselves doing that, then we could add it as a first-class citizen.
Right, but at that point it would have to be a distinct overload. We wouldn't be able to change the return. I mean, we wouldn't be able to change the return type of push sequence because that would be a an IL
I
breaking
I
change.
think you'd want that anyway, just because I know you said that every use we have is matched in the same function, but it seems totally plausible that someone would put these in little helpers or wrap them in some way, at which point you're then passing around the iDisposable, which gets hairy.
Yeah,
So I think you'd probably want them both anyway. You'd want the convenience as well as the direct methods.
Yeah.
fair enough.
So now what you should advocate is a callback model where you pass a callback into push sequence, and from within there you populate the contents.
Yeah, no, don't need that. Oh, I guess one thing. So I think I have it as a note at the end, which I can't see right now because I'm presenting. Back to write encoded value. Usually, the time that I'm calling write encoded value is when I've needed to write something in a different writer for a nested payload for complicated reasons. And then I wonder if it makes sense to have a public method of writing coded value of a writer. So copy the contents of one writer into the other, which would avoid, again, it just avoids the ceremony that you would need to do of exporting it to a new byte array or renting some space to encode it to.
Yeah.
It can always be added later.
Normally the pattern for that though is a.copy to b.
Yeah, so we can keep that in mind for when we get to the questions, and it can certainly be added later. Okay, so push sequence handles both the sequence and sequence of because they encode the same. Set of, I put the of in the name, again because of the ambiguous paragraph. A set of structure in the sur and dir encoding rules, even because the set is technically unordered, but sur and dir are all about making sure that you always use the same exact sequence of bytes to represent the same thing. There's an internal sort that has to run on the data. It has to be written in the right manner. Because no one can get this right on their own, the writer definitely does it for you. So, because the pop is using set of rules instead of set rules, I named it push set of and pop set of, and I technically don't support set. All right. Octet strings. They're kind of exactly what you think they are. So the most normal representation is read-only span a byte. It copies them. I'll go ahead and kill the span action overloads. All right, and now for a technically weird thing. So octet strings really don't make sense to push if you look at just the data language. But a lot of file formats that I've seen say that at this point in the file format, you will have an octet string containing the data, but then the data is itself another ASN encoded value. And this is one of the places that I frequently have found myself needing to create two writers and pass their data back and forth. And then it seemed to make sense of why not just go ahead and say, open the notion of we're writing an octet string, and when you call pop, I will turn it into the correct primitive value for you. I haven't actually written this. I wrote it just for the feature review.
So sorry, say how is this different than write encoded value again? I didn't quite understand.
So you would say push octet string, and then write integer, write integer, write integer, write integer, pop octet string, and then it would write down 0, 4, 0, 8, 0, 2, etc. Because right, so this would be mostly for things like certificate extensions, where the extension type says it has an OID and then an octet string, and that you need to then look inside the octet string to know what the payload is, which is determined by the OID. And But so it's you have an octet string between two pieces of, or wrapping another set of ASN data. While the reader won't really help you with that, it's not a lot of pain at the reader, but at the writer, it means that you had to go create the nested content first instead of being able to use a linear flow. So this lets you write a linear flow.
Okay, got it.
Okay. Enumerated values. ASN enumerated values are .NET enums as long as they don't have flags. Flags is next. And so I have write enumerated value. I have the generic one to be helpful and friendly, and then in tests, I frequently find myself not having strongly typed data, so I added the object one to make tests happy.
The enum value is actually an enum?
Yeah. I mean, like, you can, if you, I think if you pass an integer, I throw. But yeah. I don't remember why. Definitely in the reader will have a version that cares that it's an enum type because it needs to, type it for you on the way back out. But yeah, so the write enumerated value of object will throw if it's, so argument exception if it's not a boxed enum or if its backing type is declared as flags.
Why? I guess I'm curious why we have an object-based overload here, but not for something like the integral ones. Like, why is enum special?
This is because I added the generic for, compile sanity, and for the integer ones, it's so the generic one avoids boxing, and the overloads in write
No,
integer avoids boxing.
I get the generic one. The generic one makes sense.
Yeah.
I'm wondering why we have the non-generic one.
I mean, what would you do for someone who has a value in a reflection context, like a test?
What would you do for someone who has a value in a reflection context and was an integer?
You can call convert.toInt whatever and turn it into an integer. I don't know if you can do that with an enum.
I feel like there's no good way to get back into generic land once you've gone into object.
Well, you don't need to get into generic land. You need to get into the enum type.
Okay, so you would make it, instead of object, be enum.
No, that's not what I meant. I meant,
okay,
like, if you knew that it was a day of week, right, you would cast it to a day of week and use the strongly typed one. If you knew that it was an int, you would cast it to an int and use write integer. I'm wondering why this object one ends up being valuable, but all the other ones we've talked about, bool, int, etc., don't have the object equivalent. Like, why does this need it? Is my question.
That's fine. I think really I wrote the reader first, and the reader has read enumerated value that takes type of in case you can't have a generic context, and that returns object. So then I just made the overload that took the thing that the other guy returned.
I see.
But
there are also only half a dozen integral types in the framework. Like, there are more than half a dozen enum types, and you can define your own. So anything that is an integer can always be cast to a uint64 or an int64. Like, those two integers are universally accepting of any other integral type within the framework. No such thing exists for enum that one can just be converted to straight up. Am I misunderstanding that?
I don't know how that's relevant. I'm sorry, I'm not understanding. Like,
it means that if I have
a boxed int, I can't just cast it to a ulong.
No, but you can use convert.toInt64 and it will succeed.
Sure.
But there's no equivalent of that for enums. Like, the thing is, the framework actually provides an out for turning an arbitrary boxed value into an integer of a specified type, even if you don't know what the original type was, where a normal cast would fail because it can't unbox, but going through the convert APIs or similar would succeed.
I see. And so we're expecting the case here where someone is reading with a type, like a system.type, and wants to then feed the results to the writer.
I mean, that's where the API came from. Also, from the notion of sometimes you're a helper and you've lost your generic strong type.
You're a
But
serializer.
yeah. In fact, actually, I probably wrote it when I was trying to write a serializer, and then decided serializers are evil, and then deleted it.
Sure.
Okay.
Yeah, so I mean, we can remove it and then wait for people to have
No,
feedback
I
that
mean,
they wish they had it.
if you actually have use cases for it, that's fine.
Right.
Just
The case. Yeah. So popping more, I do think that probably the reason that I wrote it was the serializer of because it was just using generic walk and found, oh, this is an enum thing. Let's call write enumerated value, and I had no good way of getting back into a generic call context on that. I mean, I could use reflection to do generic binding at that point, but that's
Yeah, that's
an object overload.
unnecessary. At this point, though, I would probably say this parameter should be an enum instead of an object. But like Steve, did you have thoughts on that? I think you had shot that down earlier.
no, I didn't shoot it down. I just wasn't what I was suggesting. What does the reader return? Does it return an enum?
I think it'll return object, but assuming enum is the legal return value, it could certainly return that.
Yeah, that would seem to make sense. I don't know if we have any other APIs in the framework that take any enum, but we could look to them to see what they do.
Okay.
All right, took a note.
Also, should these parameters just be called value instead of enum value?
Sure.
You can hear that?
The dog? Yeah.
Yeah, I think a UPS truck drove by or something.
Congratulations.
He definitely
We
lets
still
me
get
know.
UPS here.
He
Okay.
lets me know anytime there's anything interesting happening in the neighborhood.
Yes.
So now we have the other kind of enumeration, flags-based enums. In ASN land, this is called named bit list, and this is the one place that I can think of where .NETisms and ASNisms don't line up, and so the writer and correspondingly the reader use things in at least what I consider to be the .NETisms, and now I guess we can have a debate of whether or not I'm wrong. So, what hopefully everyone can see right now is this is the named bit list definition for the key usage data type in X509 extensions. So digital signature is bit 0, non-repudiation is bit 1, etc. And now I've said this is the way that to me you would write that enum in .NET. Like naively, this is what you would assume is the right answer. Does anyone want to disagree with that? Okay. So the actual encoding on the wire is opposite of that, and variable length, meaning you can't actually know what the value should be. Because bit 0 is the most significant bit of the 0 indexed byte. And so this just does all the twisting for you because it's hard. So I'll take the same notes for renaming enum value to value and considering changing object to enum. All right. Any feedback other than the pre-established.
And does this require that the enum is marked with flags? I don't see that written down anywhere.
Yes, it's exception, argument exception, second line. The unboxed type is not declared flags
Oh, there it
attribute.
is. Okay. Yep. It's a different color, therefore I don't see it apparently. Are there scenarios where an enum might actually be flags but not be marked with a flags attribute? Or is that just not interesting from a scenario perspective?
Yeah. I can't think of a case.
Do bitwise operations even work if the enum's not marked with flags?
Yes, they do.
Or, they do. Okay.
Yeah, it really only affects things like formatting and toString.
Mm-hmm.
Yeah.
Or formatting and parsing, rather.
Got it.
I mean, it works assuming the people have set the right numbers, right? If they just have an increment, then it tends to fall apart. But that's the same point with flags.
Emo's here.
Hello, how's it going?
Well. So, okay, since I suppose we could leave this as is, mandating the flags attribute, even though you said the flags attribute's normally only used for parsing and formatting. And we would be using it in a non-parsing, non-formatting scenario.
I mean, this is formatting and parsing. It's not text, but it's the next best thing.
I mean, I would expect it to affect serialization, right? For that reason, the serialization is just parsing and formatting, right?
Okay, fair enough. Normally for serialization, you would just take the integral value and go, which is kind of what you're doing here. You're just flipping bits.
Well, like I think the XML serializer writes down the name instead of the value, and then if it's flags, it uses the toString, so the comma separated, which again is formatting, but that means that there is a precedent for the data encoding transformation cared.
And just out of curiosity, you don't need to pass in like the length of the enum, correct? Because it's written using a variable length encoding, just like regular integers.
Right. So I have.
Okay.
Yeah. So, like, I have an example of which used a 2-byte encoding of the named of the key usage above. But if you'd only specified a bit that would be in the in the leftmost byte, then the length would drop to 1. Actually, that is what I have an example for, because it's a bit string, so the third byte is how many bits were unused.
Okay, perfect.
So then if you included the decipher only, because that now needs an extra byte, then the value grows. So it doesn't need the backing size of the enum, because it already has a way that it needs to write it packed. And the non-flags encodes just as an integer, and so it'll use the same drop all the unnecessary leading bytes.
Question from chat: what about flags that don't have that aren't necessarily powers of 2 for the values?
It doesn't care.
I would assume. Yeah. Okay. Great.
It looks at the value as a bit vector. The fact that you put flags on it and passed in a value of that type means it thinks you know what you're doing.
One more question from me. Do we need a bit array overload of this? Because it is represented on the wire differently than a regular bit string, correct?
No, it's a bit string.
I thought that...
This is simply the only time that it ever comes up that you write down unused bits. I mean, technically you could with a raw bit string as well, but a named bit list just encodes as bit string. So...
really, I thought that there was a difference in alignment on where the data began Like on what was considered the most significant bit between the two scenarios?
I mean, if you call read bit string on the reader, it'll give you back the bytes. And if you call read named bit list on the reader, it will do all of the understanding what byte 0 or what bit 0 means for you. So there's a difference in the reader with the twist, but there's not really a difference in the encoding. Consider bit array load. Yeah, so bit array actually makes a lot of sense on named bit list, and so maybe we would put it on bit list and not bit string, because in named bit list there's a definition of what bit 0 is.
Sure. If you think it makes more sense to have it on one or the other, or neither or both, like I would defer to your judgment on that.
Yep, but I took the note, and I'll look into it. Okay, everyone's favorite types, dates and times. So ASN allows way too many ways that you can write things down. The writer is only going to use the two that are legal for Sir and Der. So ASN has two date time types. There's one called UTC time and one called generalized time. UTC time is the Y2K problem. So it only uses 2-digit years, and because it was written in the 70s, it can't change. And so we have complications for dealing with that in the reader, which we've allowed extending into the writer a little bit, which we'll see in a moment. And then generalized time is a 4-digit year, which also includes fractional seconds, because why do one thing when you can do two? And then there are rules on fractional seconds, which we'll get to. So the simplest form of UTC time is given a date time offset, write it down. So it will to universal the value for you, and then it will write it down according to the rules it needs to. And because you provided the value, it will accept any 2-digit year as a valid 2-digit year, and it'll just write it down. Okay. The other overload. So now we get into question of when we start overloading, where do we really think the tag goes? The other overload allows you to specify what you wanted the 2-digit year max to be. So in the case of X509 certificates, the 2-digit year range is defined to be 1950 to 2049 for reasons. And so if you pass 2049 as 2-digit year max, but you give a value that's in 2050, then it will throw of you're writing an illegal value. So this is simply callers not writing the if it's bigger than the value I want themselves. We encode that. And really this is because we have it on the reader because it needs to interpret the 2-digit year. Okay. So Steve, since you didn't like the tag at the beginning, where would you put the tag in write UTC time? Second or last? Okay. So just standard.
Did I pass?
Yeah. I mean, this is where it started in getting weird because now we have write UTC time that takes just a value, write UTC time that takes a 2-digit year max. So would you have the forpal of so date time offset, then date time offset tag, then date time offset int, then date time offset int tag? Like just move tag to last in all of the overloads that have it?
I would move every overload that has a tag. I would move it to the end.
Okay. So you think it's cancellation token. All right.
Can we make the tag defaulted?
The only default value it can have is, because it's a struct, it would It would be a tag that you're not allowed to specify
Okay.
because the 0 byte value encoded tag is a reserved word. So I mean, we could do that, but it feels weird because now we're accepting an explicitly illegal value and then changing what its meaning is.
Can the 0 value be the universal value?
The 0 value tag is so universal 0. It means if you are a list that uses an I don't know how long I am encoding, which is called the indefinite encoding, it's the tag that tells you you've hit the end of this list. So
Okay.
it's technically not a tag, but an encoding marker, and they kind of are emphatic that it's not a tag, but I call it a tag because everyone calls it a tag. So,
Sure.
So this last overload is the only one that would be interesting. Like if you move tag to the end, it can't be after something that has something that's an optional parameter.
right.
So
I mean,
that'll omit fractional seconds. We would just remove the equals false, right?
yeah. So I mean, we could make the quad overload of right generalized time, so that there's no default parameter, or we just
I mean, there
move tag to the last non-default value.
you could also make it nullable, but that's a bit. I'm not a huge fan of nullable structs, but
Uh,
and then default the value to null.
so you want nullable tag?
Well, I'm saying it is, if we wanted to avoid overload explosion, that is one way to do it.
I mean, that is explicitly the difference between you've given me a value and you haven't. So does that mean that we would generally go back to all these things and move tag as the last parameter, change it to nullable, and default it to default?
I mean, that would certainly make sense based on what you just said.
Okay. So writer general make ASN1 tag overloads, take it as a defaulted nullable.
Is it optional in all cases, or are there cases where it's required?
There is no method group that requires you to pass an ASN1 tag. When we get to text strings, we'll see that we come really close to needing it. Okay.
Yeah, because if it's the only reason I say that is because if there are cases where it's required, then the rule of keeping it last might be tricky. If other
Right.
optional ones before that.
Yeah. In every method in the writer, there's currently always a way that you can do something without ASN1 tag being specified, so that we can make it a defaulted nullable value, and that'll work fine. Okay. So why do something one way when you can do it, I think 9 or 10 different ways, which is the number of different ways that you can write text strings in ASN1 encoded data. So there's UTF-8 strings, numeric strings, printable strings, T61 strings, also known as teletext strings, IA5 strings, visible strings, BMP strings, graphical strings, universal strings, and some others. So when I started writing this, I originally was going with if there's a named data type in the spec, there's a named method group, and it just got stupid. So this is what I came up with instead, is write character string, and you pass in the universal tag number enum value to say which kind of string you thought it was. So if you're giving an explicit tag, so you're saying this is a context3 string, but it needs to use visible string encoding, you would give the tag as context3, universal tag number is visible string, and then the string.
So I have to look at your PR.
And then I see that there was a question in the chat about why support the 2-digit strings at all, because certificates say you have to use UTC time if the date is less than 2050 and have to use generalized time otherwise. So there are cases where if the thing says it's UTC time, you have to do it. So that's why the writer supports it. All right.
Sounds like reality is kicking in. I see. So why character string? Why not string? We already have read string.
We already have bit string and octet string, and
I see. Okay.
and so it's making it clear that this is a different kind of string than those other strings. We can remove the word character if everybody thinks that it's non-ambiguous.
I mean, to me, it's like if you say read character string, I'm always inclined to say what other strings. But if you already have other strings, it makes sense.
Right.
Like, I mean, given that you have bit strings, it might make sense to say character string.
Yes. Okay. So if there's no other feedback on write character string, that means we have now finished the writer. Hooray! Hooray.
The reader is short, right?
I mean, the reader is not going to introduce too many concepts that we didn't get in the writer, so it should be a fast read, or a fast evaluation. We'll see.
No pun intended. Okay.
Yeah. Okay. So AsnReader is a class. This proposal later we'll talk about AsnValueReader, which is a ref struct, which we'll talk about when we get there. So since it's a reader, it can take a read-only memory and hold on to it. It does not make defensive copies. The onus is on the caller to maintain data integrity through the execution of the reader. And it takes a rule set. And anytime it's reading, if something violates the rule set, it's going to throw a whatever we decide exception. All right, since you gave it a rule set, you can get the rule set back out, but it will not give you back the read-only memory because it doesn't want to. There are so there's the Boolean property has data, which is it hasn't yet hit the end of its payload. And then there's the utility method throw if not empty, which just replaces a lot of boilerplate code of if has data throw data existed beyond the end of the defined structure. And then the next thing that someone would want to do is peak tag. So I think I had a thing earlier that said I used the word, so peak means it will return the value without advancing the reader, and read means it will return the value and advance the reader. There's also copy, which we'll probably rename to read when we get there. Okay. Any feedback on the boilerplate structure?
So I think throw if not empty. I think there's a guideline that says don't have those APIs, right? Don't we have that?
I don't think we have that because cancellation token.throw if cancellation requested is exactly that API.
Yeah, I think the rule we have is like don't have booleans or something like this, right? That. Yeah, I think maybe that's the one I'm thinking of. I think it makes sense to me. I mean, I actually like APIs like that. They look ugly, but I find them very useful.
Okay. So this next set of operations called direct data interaction. Again, this is the if something weird is happening, get the reader out of the way. So if you run into something that we don't support, how do you deal with that? And so again, everything is tag, length, and value. So if you've already done peek tag, you probably don't care about the length bytes, and then you could peek at the encoded value. So this will skip the tag and the length, and then just give you whatever's left. And since you gave the memory, it'll give the memory back to you. But it's only for the one value. And then there's peek encoded. Actually, yes, I said that wrong. Peek encoded value is the tag, the length, and the value. Peek content bytes is only the payload portion. And then there's read encoded value, which is a fancy word for skip. But while skip would be void, this returns the data to you. So this is reader, give me the next value. I don't, and I'm going to do something with it. You don't. Just move on to the next thing.
Right.
Okay.
So the memory that you gain from these peek methods is memory you don't own, right?
It's memory you do own.
It's
You
still-
provided it in the constructor.
Sorry, but I remember that is like I'm not responsible for freeing that after calling peek, though, right?
Correct. So all of the methods that return a read-only memory are returning a slice of the original buffer.
Right. So there's no copying, basically. So I'm trying to get it. Yeah, that makes sense. Okay.
Right. The things that need to copy when they need to copy are more complicated, and they return byte array in the simple methods. Okay. Oh, and this is a detail that I glossed over in the writer, which I'll just state again here. So when we looked at the tags, we saw that every tag has a bit that says if it's primitive or constructed. None of the reader or writer methods care. They only look at the class and value of whatever tag you pass in, but the peek tag will tell you what is exactly encoded in the stream, which is the reason that it still exists in the struct. So if you say that you want to read a constructed Boolean, even though there is no such thing as a constructed Boolean, it will just say you're reading a Boolean. All right. So again, we can. There's a little bit of work that could be done on the exception model. One thing that I've been So the existing model is very opaque. Everything throws a this value is illegal exception because that's what we got when we called win32. And I've been thinking that for the reader, it would be nice if it told you things like the length exceeds the payload or the amount of payload remaining versus read Boolean of in SIR and DIR modes, there are only 2 legal Boolean values, but there's a byte, so there are 253 illegal Boolean values. And so then if it were to throw that the content is not encoded according to the encoding rules or whatever, then you would at least get a hint of what you need to do to correct this action, as opposed to it just tells you this is wrong. So there may be multiple exception types or just multiple exception messages. But that's slightly being skipped right now.
Why would you need different exception types, though, right? You don't really expect the caller to handle them differently. It's just that if you look at the message, it should be actionable, right? But clearly, there's not really something you can do on the consuming side in code, right? It's just write a different program or give you different data.
Right. I guess one of them tells you whether read encoded data or read encoded value is going to also throw. But that's probably a super corner case that you could just write the try yourself.
Right.
Okay, read null, which is really validate and skip. because it's null. And then, so yeah, currently here I have two different versions of read object identifier. The reason for read object identifier is string is because it saves on both memory allocation and some annoying dictionary lookups that sometimes happen over a network in the OID constructor. But I think I want to just, even though we have a strong type called read object identifier, I think now I want to change the proposal to say read object identifier returns a string, and there's only the one version. Levi?
I'm having a lot of internet connectivity issues right now. Sorry.
I mean, so Jeremy, if you did that, you could always construct the OID from the string, and I guess we're just assuming that it's a rare need.
Yeah.
Yeah, seems fine.
Yeah.
I mean,
Yeah, so
what would you have to do?
So if you
So
wanted,
is it
if you wanted the OID
is
rich
it as
type,
simple as
go ahead, Emo.
sorry. No, is it as simple as saying new OID string, or do you have to do something more involved in that?
Yeah, it would just be new OID of reader.read object identifier. That constructor does a lot more work than you would think it does, which is why I made the one that avoids it. But if the caller wanted the OID rich type, it's as simple as just saying new.
Yeah, I guess at that point it just depends on. But if like it's the same thing we have with URI, right? Like if the vast majority of people don't have URIs, but they usually have strings. That's why they have usually overloads that just take a string. So people, not everybody has to do the bullshit new URI string in, right? But like, if the vast majority of your customers don't need an OID, but they just need a string, I think just returning a string makes sense to me. If almost everybody needs an OID anyway, then I guess I would just only go with the first one and then just say screw it.
Yeah. Like I know in Win32, there are things that are, interpreting these payloads. They actually just look at the next raw data and do a mem comp against the pre-encoded value of whatever the OID would be. I tried switching some of our code to do that, but it's really hard to make a dictionary that does a lookup based on a span. So I haven't done that yet. But yeah. Okay, so just change to public string read object identifier and get rid of the complication. All right, integers. They were very easy to write. They are very annoying to read. So the easiest version is just give me the bytes. So read integer bytes is validate the tag and then return read content bytes, except I don't have read content bytes. I only have peak content bytes. But effectively, that's what it is. It's just here is the raw data. You figure it out, please. Because
how many bytes can you have? Is it just up to long, or do you have support up for indefinite?
2 to the 255.
Okay, shit, that's a lot.
So more. It's legal to say that your integer is bigger than the universe. Sorry,
cool.
2 to the 255 minus 1. I don't know. There's a minus 1 somewhere. Naming things is hard. Right. So the natural type that this corresponds to is big integer, and so that's why I've given the simplest read integer the return type of big integer. Because if it's arbitrarily big, if it's negative, like all of these values can still go into big integer, and now you can do whatever you want from big integer. And then, but because you probably only want an int, there's now try reads, and we can decide how many of them we actually want. So the try reads will return. They will throw if the value is not an integer. So if read integer would have thrown, then these will throw. But if the value does not fit in the data type that you have specified, then it will return false.
Gotcha. And have we said that as in one tag should be optional, or are we saying there here's separate overload?
Oh yeah, we didn't specifically address that for the reader. Um, I mean, we can do the
So it's
same.
going to be,
Go ahead.
yeah, I was just thinking there will be fun with the out parameters, right? Because then it gets, where would you put this, right? But yeah.
Right. So if we made it a default, a nullable default in the reader as well as the writer, then it would just be outint value, comma ASN1 tag question mark expected tag equal default, and
Right.
I think that'll be fine. So I'll take the same note of default all the tags.
I think that would make sense, yeah.
Okay. So how do we feel about having 32, 64, 16, and 8?
We
So,
don't normally use int 8 and uint 8, but yeah. It makes more sense in try read byte though.
Yep.
Given the scenario.
yeah. I guess I have a more meta question. It's like, do you, like, what, so every time you have a read API that has an expect, will they throw when the tag doesn't match?
Yes.
And so what is the reason that some of them have try and some of them don't have try?
Right. So try read int 32 if the value does not fit within the range of numbers that int can represent, it will return false. But if the reader is pointed at an octet string, it will
Oh,
throw.
I see.
So the only
see.
benefit of the
Got it.
16 8-bit versions is to validate the value is to like eliminate the need to write an if value greater than 255 throw.
Or if you were outing it to a field.
In which case so they really are convenience.
Yeah. I mean, because
Yeah.
all of these are we could just have read integer. You get the big integer and you deal with that.
In this particular case, I would say just out to a temp integer and then narrow and assign to the field yourself.
Right.
Right. Because shorts and bytes as integers seem. Yeah.
Yeah, I just killed the last 8.
Okay. So leave try read int 32, uint 32, and then the 64 versions as well. Okay. Essentially, our
I mean, I assume
common register
our
widths.
reasoning is that, yeah, I guess our reasoning is that they're more common. I mean, I don't know enough about the file format. Is if bytes were super common, then it would suck to cut the last 4, right? But
Well,
assuming that the vast majority of numbers are in 32 and in 64, then
yeah, I mean,
Oh, but it's not preventing you from using bytes. It's just not doing the validation that the byte is actually a byte.
yeah. So if the value is
that's what I'm
3,
saying. If it's
yeah, if the value is 3, try read int 32 will still represent it. It
Right.
doesn't. The payload was only 1 byte of content, but it can expand that up to int 32 for you. The try read int 8 would just be for if you were outing it to an S byte field, because you can't do a data type coercion in a ref assignment.
right. No, I mean, like, I get that. All I'm saying is that if it's common for people to have to read bytes, right, where the idea is that, yeah, I expect a value between 0 and 255, then cutting the last 4 would not be great, right? If the vast majority of people will not do that, then that reasoning makes sense to me to
Right.
cut them.
I think
what I'm
it's-
saying. I don't have enough domain knowledge
Yeah.
to make that decision.
While I've written some try read int whatever and check if the value is less than something, usually the specs that I'm doing will say that the value has to be, less than 100 or less than 10, and then the int 8 precision alignment isn't really helping.
Right. That makes sense.
Okay. Bit strings. So in the encoding rules, so dir bit strings must always be contiguous data. Sur bit strings, if they exceed 7,992 bits, they must always be in discontiguous data. and BUR is allowed to do whatever it wants. This means that bit strings are complicated. So the simplest form is read bit string. It'll return a byte array that has all of the data now contiguous for you, and it will tell you what the unused bit count value was. The next most common operation, so if you're dir, it will always succeed, as in it can't return false, is I think or hope this data is contiguous. Please give it to me as the read-only memory without doing a copy. So that's what I currently have named try read primitive bit string value. And then there's a try write version, which currently uses the verb copy.
So why primitive?
So primitive in this case means that the tag says this is a primitive bit string, meaning it is not created by concatenating several nested values together. That primitive and constructed are the domain terms for single value or built up of nested values. Not primitive as in like int.
Right. I see.
And so I have primitive in the name to indicate that the reason it returns false is it was constructed.
Don't have a try read bit string value then, because if it's constructed, we don't know what to do. Is that the idea?
Well, if it's constructed, we'd have to return false.
Yeah, what I'm saying is that we can't give you an API that would give you that, because it's not contiguous, right? So you wouldn't be able to return a span or a memory, right?
Right.
Yeah, okay.
And while the name is verbose, it is descriptive.
Right.
And I think everyone who will ever use the API is currently on the call or on YouTube. So, all right. So then, while we have the simple case of return the byte array and the next simplest case of it's contiguous, please just give me the slice. The non-contiguous don't create an array would be the try write pattern. And so I have that here. Of course, this will drop to just the one that has a defaulted tag, which solves the parameter ordering question. And now the question is, should we say copy because that's what it's doing, or should we say read so we only have two verbs on the concept count?
So I think copy is actually a good term here, because read and copy both imply advancing, but all the other read ones, I guess that's actually not true, because I mean read bit string also returns an array, so clearly that's copying, right?
Yeah.
Yeah, maybe we just try read then. Yeah, I guess in that case just go with try read bit string, right?
Okay. Octet strings. This is just bit strings with the word octet, and they don't have an unused bit count. So I'm just going to skip past that one.
So it would be the same pattern, right? We would then say try read octet string bytes.
Yep.
Yep, that makes sense.
Okay, so now sequence and sequence of. Oh god. All right, so read sequence is easy. Sequence, you see it's the right tag. It returns a reader that is only valid over the nested content. So in the case of class AsnReader, this is object creating, but the object it's creating is small, and the GC is efficient.
So why did you do that rather than just maintaining a nesting level or something on the reader?
Um, just because frequently when I was writing it, I found that I don't necessarily want to consume the data in the order it was written down, and so I want to be able to snap and say this was the first complex data type that I saw, and now I need to read what's after it to understand how to interpret it. So it just seemed to match what I
The
was
only
doing.
reason I'm the only reason I'm asking is because I don't think JSON Reader or AsnReader are doing that, right? They basically just give you the. But I mean, you don't have a model for the tokens here, right? So in that case, it would be hard for you to represent this, beginning of sequence, end of sequence kind of thing, where the
Right.
consumer would do the nesting, right?
Right. Yeah, because if it's um, if it's not using an indefinite length encoding, then read sequence stops after a number of bytes, and so then it would be upon the caller to track that they've transitioned states, which then makes the if we go back to the helper of throw if not empty, that one doesn't make sense anymore if you're not like it makes sense with this model because I'm reading a nested complicated type. It's only supposed to have 3 fields. Why was there data after I read the third field?
Right.
So
Are your readers disposable? No, right? You pass in memory, but the reader itself is not disposable, right?
correct, because the
Okay, so
caller owns the
then,
memory.
okay, so then I think that doesn't affect that either. Okay, that's fine.
Okay. So as I mentioned in the writer, in Sur and Dur mode's set of data types, there's a sorting algorithm that you're supposed to run before encoding and write down the data in a particular order. I think I've seen a place where someone did it wrong, and that's why I added the boolean of yes, it violates the encoding rules, but just give me the data back in the order it was represented. Um, that's why this one's complicated. So by default, I mean the other answer is that we always skip validation when reading, but I went with everything that the spec said is true. The reader validates, and set of values being sorted, the reader or the spec says is true, and then somebody's implementation didn't do.
I mean, as a matter of principle, I like the way you did it here because it's a local decision, right? I generally don't like these global opt-ins or opt-outs because they seem to be very heavy hammers. If just somebody fucked up somewhere deep in the tree, and this one allows you to just skip it in this one particular thing, and then generally you have validation on, which I think seems good.
Okay. So read enumerated values should look like I have read integer bytes, so I have read enumerated bytes because they do have different tags. Named bit list and bit string don't have different tags, but enumerated and integer do. Okay. Yeah. So this is just give me the bytes and I'll deal with it myself. Then there's the generic. This maps to this enum, give me back the value, which can of course throw if it's out of range of the enum that you've specified. And yep, here I did say read enumerated value returns enum, not object.
Yep, so further evidence and the other one should take enum.
Yep. All right.
So then why do you have read here but no try read? Because for the int ones you said if they're not in the range you return false, but here you're basically saying you just throw.
I mean, this is like if you say that you're reading an enumerated value, the spec will have called out, this is how big the enum. Like there are 12 possible values in the enum. It seems very unlikely that you would have made an enum type smaller than what the spec said. I mean, technically they could have grown it to go from a byte to a short through revving the spec, but that doesn't feel very likely. As opposed to that it's just an integer, and you want to get it as the integer. So again, the escape valve is you can read the bytes raw and deal with it yourself.
So maybe I'm missing something, but so the spec doesn't differentiate between ints of particular sizes. It's just there's an int and it's always unbounded.
Correct.
Versus for an I see.
Yeah.
So in that sense, the try is only because you read it into the .NET type system. Versus this one is, I'm reading a enumerated value, and if it's not a enumerated value, that's a spec violation rather than just a .NET type system limitation.
Yeah.
Yeah. Okay, fair enough. That makes sense then.
Well put. Thank you. Okay. Named bit list. Same examples. And looks just like the other guy. There's the generic one and then the non-generic one.
And this validates the names, I suppose, right? Or the alignment, right? I guess what basically when you say, it's not just you read an arbitrary bit pattern, right? You actually validate that the bit pattern exists.
No. So this can return back, like it's not going to do a is defined check on each bit that was set. So it can return things that are inconsistent representations or use bits that your enum hasn't defined, but it will throw if more bits were specified in the payload than your flags enum could represent.
We had talked about having the writer accept a bit array for this. Does it make sense to have the reader return one?
We certainly could for both this and bitstring, but we would need to name the method differently. So, as bit array, with a suffix.
Well, does it make sense to have it on both read named bit list and read bitstring, or should we just have it on one? Or
yeah, I mean it sort of because they're actually the exact same encoding. Using the what does 0 mean, it probably makes more sense on named bit list, honestly. So
okay,
we could do read named bit list value as bit array, which is a really long name, but I don't know how to do better.
Yeah.
So is there a way to force it to allow you to read a bits flag where one of the bits isn't represented in the enum?
Yeah, it won't validate that the enum is that your enum value is in a state that you would consider to be consistent. It doesn't ask as defined on any of the bits.
Oh, okay. I thought I heard you say there was a case where it will validate.
No, but it would throw if you made a flags enum backed by byte, but 9 different bits were specified because it.
Okay. I just misunderstood then.
Yeah.
Yeah.
No worries.
We wouldn't need a new method name, by the way. You can overload, I believe, based on the generic parameter. Maybe that's a bit evil.
I wouldn't be able. So I use the enum constraint right now, so I'd have to drop that constraint.
No, I meant can't you have one that's not generic and parameterless? Or would that break stuff?
I have because it wouldn't need the type.
Yeah.
Yes. Okay. So
if you don't specify a type or if you don't specify a generic, then you want basically a vector back. I mean, we might be designing it incorrectly on the fly here. I don't know. It was just a thought.
So that. Only YouTube can see that. I don't know how Emo does this. So
let's say yes.
So public to flags enum read name bit list value of to flags enum, public enum read name bit list value of type to flags enum, and public bit array read name bit list value. Technically it would have the ASN1 tag question mark, but
yeah.
Okay.
Yeah, that seems reasonable. Assuming that we did want to standardize on bit array being the generic way to shuttle data back and forth across these APIs.
Yeah.
Is bit array really the type you want to use? Because I don't think it was one of those BCL types that we are particularly proud of. Or am I thinking of the wrong type?
Maybe. I mean, if we don't like it, we can certainly not add it. And right now, the data is available for parsing to someone who wants to do so. But I took that note. We'll move on to the next one.
Yeah.
Okay, so in the writer we talked about the 2 times. So in the reader we have the 2 times. For read UTC time, we need a 2-digit year max. The value that I went with here is the one that X509 uses because, frankly, it's the only thing I can think of that uses UTC time. One suggestion that I got after putting up this proposal is instead of having it be a method default parameter, that maybe the reader wants to take some complicated set of options for things like, if you see a UTC time and I don't explicitly give you a 2-digit year max, this is the one I want you to use. So that will let you build a reader of, if LDAP uses a different default and uses it consistently, you wouldn't have to pass it at every single call to the method. So that's under consideration unless someone thinks I should absolutely do it or absolutely should not do it. But I would still leave the per method call.
So where would you configure this global?
So AsnReader would gain a new optional constructor parameter, whether it be overloading or default parameter, that is a set of options which would have things like 2-digit year max on it.
Nice.
So read UTC time with no parameters would say using whatever my pre-configured default max is.
Why not just a property on the reader?
Because then you can change it.
That doesn't seem
right.
But it doesn't seem bad, right? Because you only, like, when the method returns, like, it's fine, right? Like, I mean, there's nothing fundamentally wrong with saying I set it to 2049, call 5 read methods, and then set it to 2090, and then call 5 other read methods, right? That seems not necessarily problematic, right?
It does, but it makes it weird when if a helper does that and doesn't put it back to what it was. Like, it feels like it's mixing too much state to me. Like, I don't like when API does that. But so I'll leave this as is, and I'll leave that as an open investigation for what should be a quick note later.
I mean, passing it in optionally seems per method call certainly the easiest route right now.
Yeah. Okay, so on generalized time.
Yeah, I had a quick question on that. Sorry. You have as a condition the contents are not valid under the current encoding rules. Does that also handle like January 80th?
Yes, I think so.
Okay.
The majority case that it would mean for a thing that would otherwise be legal is in Sur and Dur you can only specify times in Zulu time. Despite the fact it's called UTC time, Burr is allowed to write it down as a time with a time zone offset.
Great.
Because it's a flexible spec. But yeah, essentially I think because the date time constructor itself will throw, like, I'll just read out January 80 and I pass it to date time offset and it says this made no sense. But that may mean it's a different exception type, so I probably have a test for it somewhere.
Okay, that's fine.
All right. So read generalized time. Generalized time. Some of the X509 specs say things like, and do not encode fractional seconds. So when I originally wrote this, I allowed the option to say, if you know that fractional seconds are a spec violation, we can make this throw here with a normalized this is encoded poorly. But if people think it's weird, then we can just make the callers who care check on the thing themselves and ask what the fractional seconds are and throw if it's not 0. Like, I know of one place that does this, but it was sort of the last thing I was doing before writing the reader, so it was high on my mind.
Yeah, I would honestly just have the caller handle that condition, honestly, because it is, as far as the dir sur bur format itself is concerned, it is valid to have fractional seconds, right? It's an application level concern to disallow it.
Right. It'd be the same as as a spec saying this integer must be less than 100, and I haven't encoded any of those other things here. So.
Yeah, I would say for app level concerns like that, rather than payload correctness concerns, like I wouldn't include APIs for them.
Yeah. Yeah, really it was there of, if you see this, we can throw the exception now instead of do the rest of the parsing logic, but it's not super complicated, so.
Yeah.
Or super common. Okay, and character strings. So the simple one is read character string, and you tell me what kind of string you think it's encoded as. This is the closest that we get to where a tag has to have been specified to something. And then there's read character string with where if you did specify the tag, if the tag you give is universal and it doesn't match what you passed for universal tag number, that's an exception because you've asked for nonsense. Otherwise, the encoding type is used to look up the system text encoding class that we have that corresponds to the data type. And so it has every piece of complication that we could possibly have, and we can decide what we want to trim out. So there's read character string, which returns the string. There's try copy character string, which puts it in the span of char that you provide to it. There's try read primitive character string bytes, which is give me the contiguous data if it looks like it's the right kind of thing. And then try copy character string bytes, which is don't run it through the byte to string transformation, but do normalize it into a contiguous buffer. The real reason for having the escape valves on these is I don't support all of the string types. There's one called general string that LDAP people want me to add, but there's a thing that we need somebody who understands encodings more to help us get through the spec, because it says words none of us understand, which is why I don't support it. And but there are other character string types that just I've never seen, and the encoding wasn't super obvious, and so this is all just for escape valves.
So the ones that take the span byte destination, then, just to clarify, they don't try to interpret, they don't try to validate, they just basically concatenate appropriately and then hand you the buffer.
Yeah, which
okay.
Makes me wonder why I have the universal tag number in the method, but I don't remember off the top of my head.
Sure. I could imagine some scenarios where the application might need to check that the input says it's in a particular format, but that we don't have the ability to actually do that validation on their behalf.
Right. I think that what happened is the one that currently has 3 parameters for try copy character string bytes was intended to be like, that's the accelerator for passing in the right tag that you wanted. So it's possible that now try copy character string bytes is the only thing that needs a tag, because it can't figure it out from context. Or we could just say the overload, that one overload takes universal tag number and the other one takes the tag, and it just trusts the tag number that you gave. Because it doesn't need the encoding, so it doesn't need to look it up in the table. I mean, I guess it is a little weird if you passed in integer, but all that I was going to do is throw an argument exception on that anyway. So,
yeah, if you can't actually use the data or use the parameter for anything, then probably simplify and remove it.
Yeah. All right, so I'll take the note that may be a dead parameter. Okay, so we are technically over time, but I do want to try and briefly, if anybody still has a few minutes, address the the struct or the span version of the reader. So there are two different high-level options that come to mind. One is what I've proposed here, and is the thing that I added in .NET Runtime a month or two ago, is ASN value reader, which is the mutable ref struct. The other option would be the ASN value reader is just utility methods. So it can only do one thing at a time. It doesn't maintain state. It just answers questions.
Yeah, as a higher level, this is necessary because this does show up on hot paths.
Yeah, I mean, this is, in things like SSL stream on Mac, the ASN reader is popping up. We were getting like while reading the chain on a Mac for SSL stream, we would create like 150 readers.
Okay.
Which is just means that doing a connect and getting that handshake or getting the callback firing means that we then just created a Gen 0 collect on that operation by itself.
But that alone would just make it a struct instead of a ref struct. The refness comes presumably because we're wrapping a span. So in those situations, the input is a span?
In those situations, the input is usually a native pointer that we can do whatever we want with, but span is the most honest interpretation, yeah.
Right, okay.
This is for all the places that I created the, what was it, pinned array memory manager? That lets you promote a span into a memory by promising that you're not going to let the data move. But yeah, so after I did this and I cleaned up a bunch of the stuff to use it, I then had this feeling of maybe what I should have done instead was just utility methods, which probably still need to be on a different type because they would be changing static versus non-static for the same name. Of it can tell you, oh, this is what the next value looks like, and then it loses all the parts where it just slices and moves forward. So it can still take spans, it just doesn't have state. How does anyone feel about one versus the other as a macro approach?
No real preferences, it sounds like.
Yeah, because I mean, our guidelines do say do not have ref structs and do not have mutable value types, and this is both of those. So, from a pure guidelines perspective, as the one who most recently updated the book, I should not have proposed this.
Is this being used by enough people or in high performance situations that a struct-based reader makes sense? Can we leave it out potentially?
I mean, we could it popped up on when Tomas was doing some profiling of SSL stream. It popped up as a why are we creating all of these things, and that motivated me to pursue what the value reader would look like. I think that it probably makes sense to still have the utility methods to let something work at the span level without all the places that we like in reading certificate file formats on asymmetric algorithm objects. We take read-only span of byte because that's all we need from a conceptual purpose, but because we use the reader, it then lies, and it makes a wrapper that lets it get promoted to a memory because it promises it's going to keep the data pinned the whole time, and then it reads the stuff and then it discards the memory manager. And maybe that's enough ceremony that we want to do, or maybe it's enough ceremony that says that really there is value for being able to operate on spans. And I wasn't sure, so I pulled this in to see how we felt about it. But yeah, so I guess there's do it as utility methods, do it as a ref struct, and don't do it, I guess is Corey's third suggestion.
What state would the ref struct have within it, other than just slicing the span that it has?
The rule set and the so what rule set is it operating under, and what's the current slice point? So every method would gain those two things as parameters.
Sure.
Presumably, instead of returning span, we could return a range.
Yes. And we wouldn't have peek versus read because everything would just be analyze and return.
Yeah, and you wouldn't have to take an additional read-only span of byte data on your utility methods because you were already taking one, right? So that wouldn't be a new parameter being added. The only new parameter would be the encoding rule set.
Well, it would be like public static range, read encoded value, read only span of byte data, ASN encoding rule set.
Yeah, what I'm trying to figure out is if we wanted to have utility methods, like would they look unusably different than having this value reader? And okay, no, I know what you meant. Okay,
yeah.
Ignore me. It's been a long month. It will continue to be a long month.
No worries. But yeah, so that would essentially it would be every method that this has, which is it's just copy and paste of the class with memory turned into span, and AsnReader turned into AsnValueReader. And so then it would just be all these methods would turn to static. The two parameters that go to the constructor would go to every method as the first two parameters, and then we would have. Then you could operate on things as individual values, and if you wanted to write a state maintaining thing yourself, then you could. And I think I might be leaning toward that because of my cognitive dissonance, as Emo points out.
You saw that already.
Yeah, my phone lit up. All right, so I will pursue that one, and then I'll probably need to bring something back to talk about the open questions and suggestions. And then, as we discussed at the beginning, there's still the question of the namespace, but we will deal with that later.
Okay.
This is an email thread on this one now.
Yeah. All right. Is there any other feedback that anyone has before we call it a day on this?
I just want to point out that I think you did a really great job hosting this whole thing. It was great.
It was great.
Thank you. Modulo, the one thing that you need to teach me how you show API update suggestions. Since I showed it to YouTube and not Teams. But yeah, we can talk later.
Well, because you probably share you probably just shared your browser window rather than showing the entire screen. So I usually just share the entire screen, and then whatever window I drag on that screen, I share with YouTubers and Teams.
That's probably true. I probably hit application instead of display.
Yeah.
Fair enough. All right. So tech goof, first time.
Thanks, Jeremy.
You did better than I did on my first 100 attempts, so it's all good.
I had a good teacher. All right. Thanks, everybody. We're going to call it a day, and see you next time.
Sounds great. Bye-bye.